Welcome to chapter 11 called More on Experiments, Confounding and Obscuring Variables. So here we're going to go a little bit deeper into this material. Specifically, we're going to talk more about threats to internal validity. Remember, internal validity means did the independent variable really cause the difference in the dependent variable, right? Or is there some confounding variable? And we're going to talk later on about null effects. What if we don't find a difference? How should we interpret that? But first I'll continue with three examples that the book gives for what it calls the really bad experiment. So, three examples of this. First example. Nikhil, a summer camp counselor and psychology major, has noticed that his current cabin of 15 boys is an especially rowdy bunch. He's heard a change in diet might help them calm down, so he eliminates the sugary snacks and desserts from their meals for 2 days. As he expected, the boys are much quieter and calmer by the end of the week, after refined sugar has been eliminated from their diets. Conclusion: removing the sugar from the diet caused the boys to calm down. Second example. Dr. Yuki has recruited a sample of 40 depressed women, all of whom are interested in receiving psychotherapy to treat their depression. She measures their level of depression using a standard depression inventory. At the start of the therapy, for 12 weeks, all the women participate in Dr. Yuki's style of cognitive therapy. And then at the end of the 12-week session, she measures the women again and finds that on the whole, their levels of depression have significantly decreased. Conclusion: it was the therapy that reduced these women's depressive symptoms. Third example. A dormitory on a university campus has started a Go Green social media campaign focused on persuading students to turn out the lights in their rooms when they're not needed. Dorm residents receive emails and see posts on social media that encourage energy-saving behaviors. At the start of the campaign, the head resident noticed how many kilowatt hours the dorm was using by checking the electric meters on the building. At the end of the 2-month campaign, the head resident checks the meters again and finds that the usage has dropped. He compares the two measures, pre-test and post-test, and finds they are significantly different. Conclusion: the Go Green campaign caused students to use less electricity. So all of these three are examples of a really bad experiment, and the conclusions are totally not valid. Why is this particularly designed so bad? Now, I have to add here, in my intro psych classes, I often tell people to design an experiment based on a certain question, and this is the type of design lots of people come up with. In other words, this type of design seems to match with people's intuition. So we may intuitively gear towards this design, but it's nevertheless really, really bad. In every single design, we have they're the following. It's called a one-group pre-test, post-test design. In each of these three examples, at the following structure, we have a set of participants. We measured them once, what we have called the pre-test, right? Then we intervene. We, in example 1, that's reducing sugar content. In example 2, it was the therapy. In example 3, it was the Go Green campaign. And then we measure again and we see a difference. Conclusion: the difference between pre-test and post-test is because of the intervening treatments. Now, why is this conclusion false? Why can't we jump to this conclusion? Because there are too many confounding variables. And all one-group pre-test, post-test designs have those in common. So I want to look at 6 potential internal validity threats. to this type of design. All right? And you need to know those. So you need to know their names because, I'm going to ask. Maturation, history, regression, attrition, testing, and instrumentation. Meaning that every time we have one of these designs, one of these one-group pre-test, post-test designs, all of these 6 are potential confounds. Anytime we have before and after testing and we see some kind of difference, whatever design, we have potential that any of these 6 confounds can rear their ugly heads. So, example, those boys in that cabin in the first experiment, right? We concluded that they had gotten less rowdy because we removed sugar from their diets. Is that why they became less rowdy? Alternatively, they may have become less rowdy simply because they've gotten used to the experience and they've settled into a routine. In other words, they may have matured. The participants' behavior may have changed on their own because of some factor in the participants, and that has nothing to do with the intervention, right? So that's called a maturation threat. The internal validity of the study is threatened by maturation. In this case, maturation refers to any change taking place in the participants themselves that is independent from the study. Similarly, in example 2 of the depressed women, perhaps many of the depressed women would have improved naturally on their own, thus reducing the average. And again, that may have had nothing to do with the intervention. Right? Every time we have one of these one-group pre-test, post-test designs, there's the potential that the difference that we observe, if we observe any difference, isn't caused by our intervention, but is just caused by participants changing by themselves, naturally, because of their own experiences that have nothing to do with our study. How would we control from that? How would we prevent maturation threats in our design? Well, the obvious example is to use a control group. We would have a similar group of kids who act as a control group where we don't withhold sugar. Or we would have a similar group of depressed women who don't undergo therapy, and we measure those 2 groups at the same time before and after. Right? A control group helps us see if there are any maturation threats. So perhaps if we see a maturation threat, the effects of maturation in the control group, perhaps if we have a group of depressed women who don't receive therapy and a group of depressed women who receive therapy, and we see the group of women who don't receive therapy improve, perhaps that's because of maturation. But if the group that do receive therapy improves more than the group who don't, then we know that this difference here is caused by the therapy, right? So the use of a control group helps us prevent the threat posed by maturation. Our second potential threat to the internal validity is referred to as a history threat. Let's take our third example, that of the dorm house where we measured electricity use and then had a Go Green campaign and then measured electricity use again, and we saw that it had reduced. Right? What if something else had happened in the meantime? Not the intervention, but something else that caused a reduction in the use of electricity. Perhaps, if we first measure in September and then in November, perhaps the weather has gotten cooler and people just stopped using their air conditioning less. Right? That's called history. Something happens other than our intervention, some outside factor other than our intervention caused the change in behavior that we're measuring. Right? So we call that a threat of history. Anything that happens in between makes it uncertain whether we should attribute the difference that we observe to our intervention or because of any other thing that may have happened. How do we control for that? Once again, we can use a control group, right? We can have a control group. For instance, in our study, we could have one dorm building that receives this Go Green campaign and another dorm building that doesn't, and we can compare the two control groups, right? If the one that receives the campaign reduces more than the one that doesn't receive the campaign, that we can control for some degree for history threats. The third one I want to talk about is called regression, or more accurately, regression towards the mean. What is regression towards the mean? Let me give you an example. Right? If I look at the first quiz in this course, and I look at the 5 best scores in this quiz. Okay? I take the 5 students who performed the highest in the first quiz, and I take those 5 individuals and I look at their grades in the second quiz. And I compare the average of these 5 in the first quiz to the average of just those 5 in the second quiz. Do you think their grades would have gotten better, stayed the same, or gotten worse than it was in the first quiz? Chances are that they would have done on average worse. Of course, not all of these 5 perhaps, right? But on average, chances are that they've done worse. What if I took the 5 worst students, the 5 who performed least good in my first quiz, and I looked at their average grade in the second quiz, or again performed the average grade in their first quiz, and I compared that of those same 5 people, compare that to their average grade in their second quiz. Would you think that those 5 individuals now the worst ones, right? Do you think they've done in the second quiz equally worse, gotten even worse in the second quiz, or do you think they may have gotten better in the second quiz? Well, chances are that the 5 people who did best gotten worse. The 5 people who done poorest got better. Why? Because if we take the extreme scores, either the worst or the best ones, chances are that some people are just having a bad or good day, that they, right, if I take the best scores, that some of these people happen to have guessed right on some of the questions, or were having a particularly good day or a good week where they were completely able to focus and everything. Likewise, if I look at the 5 worst students, chances are that those people, some of their performance was because of bad luck. Right? Some not, perhaps, but some of it was bad luck. So some of those 5 good ones were to some degree to good luck. Some of those 5 worst ones was to some degree to bad luck. Again, not all of that, but some of it. And the thing is that bad or good luck is unlikely to repeat itself. Right? So those who guessed right are unlikely to guess right 2 times in a row, and some of those who had a bad week are unlikely to have a bad week 2 times in a row. And that means that if you take the best scores and test them again, chances are they're going to be less good the second time around. And if you take the poorest scores, chances are they're going to be less poor the second time around. That phenomenon is called regression towards the mean. And that happens every time that you take extreme scores. In our examples, consider those depressed women, right? That's an extreme score. When you're depressed, you are scoring particularly low on mood. So chances are that if you test again, you're going to be less extreme, because that first time, that low mood could be, because of situational factors that are unlikely to repeat, like